Hey guys, let's start with the next special form. So this is the form where you have terms of x, y, p and q and they can be written in this form. The x and p can be separated to one side and y and q can be separated to another side. So in this scenario, only your fz is 0. So your auxiliary equation becomes dx by fp is equal to dy by fq is equal to dz by pfp plus qfq is equal to dp by minus fx is equal to dq by minus fy. So we will either use this or we will use this. So dx by fp is equal to dp by minus fx or dy by fq is equal to dq by minus fy. So you can write this as fx dx plus fp dp is equal to 0, or fy dy plus fq dq is equal to 0. So let's continue with this one. So what is this basically? This is your differentiation of some function that is made of x and p. If differentiation of this function gives you 0, that means this function is some constant. We can write this constant as a. Similarly, this function of y and q will be some constant. So let's try a question. If you do the question, it's actually much simpler than learning all of this. Just remember that you can write the function of x and p or y and q directly as a constant. So let's take this. P square minus q square is equal to x minus y. So you can write this as p square minus x is equal to q square minus y. So it is p and x on one side and q and y on another side. So let's write this equal to a. So your p becomes a plus x root and your q also becomes a plus y root. Now dz is p dx plus q dy. So dz is equal to under root a plus x dx plus under root a plus y dy. So let's integrate this. You get z is equal to a plus x raised to 3 by 2 divided by 3 by 2 plus a plus y raised to 3 by 2 divided by 3 by 2 plus b. So this becomes 2 by 3 a plus x raised to 3 by 2 plus a plus y raised to 3 by 2 plus b. This is the final answer. Now let's look at our final special form. This is special form number 4. It is also called Clairaut's form. This has all x, y, z, p and q. But it is in the form f is equal to z minus px minus qy minus some function of p and q is equal to 0. So here your fx is equal to minus p, as if you differentiate this with respect to x, you will get only this minus p. Similarly, Fy will be minus Q and Fz will be 1. So now let's see how this modifies our auxiliary equation. Guys, whenever I'm explaining how it modifies the auxiliary equation, please keep the original equation right in front of you so you can understand what I'm doing. So this becomes dx divided by Fp is equal to dy divided by Fq is equal to dz divided by Pfp plus Qfq is equal to dp divided by 0 is equal to dq divided by 0. So dp is equal to 0, that means p is equal to a, and dq is equal to 0, that means q is equal to b. So basically your equation becomes z is equal to ax plus by plus some function of a and b. So this is the most simple form, because what you have to do, you just have to simply replace p with a and q with b. Let's take an example. For example, the question is z is equal to xp plus yq plus log of pq. So you just have to replace p with a and q with b. This is what you have to do, but make sure in the exam you write down the auxiliary equation. You have to show this equation in the exam. So here your answer will become z is equal to ax plus by plus log of ab. That's it. That is the answer. So now what you need to know is, in this final form, in this special form, Clairaut's form, there is something called a singular integral. This is basically your complete integral. Singular integral is when you remove the constants as well. You have to remove a and b. So for example, let's take this question. Z is equal to px plus qy plus p square plus q square. So here first I'll just replace p with a and q with b. So ax plus by plus a square plus b square. This is your complete integral. For singular integral, what you need to do, del phi by del a is equal to 0 and del phi by del b is equal to 0. Here phi is basically this function written all on the LHS, which means z minus ax minus by minus a square minus b square is equal to 0. You just take all of this to the LHS and write it equal to 0. Now let's find out this. So let's differentiate this with respect to a. So you're gonna get minus x minus 2a is equal to 0. So you got a is equal to minus x by 2. Now let's do del phi by del b. You'll get minus y minus 2b is equal to 0. So b is equal to minus y by 2. So now you just have to replace a and b in this equation and you'll get your singular integral. So your final answer becomes z is equal to minus x square by 2 minus y square by 2 plus x square by 4 plus y square by 4. So let's simplify this. You'll get z is equal to minus x square by 4 minus y square by 4. Or you can write this as 4z plus x square plus y square is equal to 0. This is the final answer. So these were all the special forms. We just have one topic left, and after that we'll be done with this chapter. If you have any doubts in up till now, you can leave them in the comment section. I'll make sure I answer. Thank you.